Hey, in this video, I'm going to show you how to do a security audit on a smart contract. But before we go into the video, I would like to give a huge shout out to the Cyfrin Updraft team because I've actually learned majority of this stuff from them. And I believe their process for auditing a smart contract is outstanding. So I've taken a lot of knowledge from them and I'm going to show you how to do a security audit. Now, we're not going to go really deep into it, but I'm going to show you the basics so you can have a look at the code base and see if you can find any vulnerabilities, and if you can find vulnerabilities, how to document those vulnerabilities so that you can hand them off to the team, or you can even have them for yourself, okay? Now in this remix environment, I've got two files. I've got the Vault file, which is a simple Vault smart contract, and I've got the findings.md file, which is where we're going to put all of our findings. Now I've intentionally created this smart contract to only have one severe vulnerability, which we're going to have a look at now, and then I'm going to show you how to document and report that finding, that vulnerability, in the findings.md file. But let's actually have a little walk through the smart contract itself. Obviously, the first thing we always have to do is state the license and the version of Solidity that we want to use. And then we're going to initialize or define the smart contract. In this case, I've called it Vault. And then we have two variables. We have an address public owner and a mapping from address to uint56, which is meant to keep track of the balances of the users that deposit inside of the vault. So if we take an address, it should give us the amount of tokens, ETH, whatever thing we're using as currency. It will give us the balance that a specific user has. And then we have the constructor, and every time the smart contract, well, when the smart contract gets deployed, the owner is going to be set to whoever is deploying the smart contract, to that message sender. Then we have a function with some NAT spec, and it says this function allows a user to deposit balance in the vault, and it is external payable. And we have the balances of the message.sender, which is the mapping up here. So like I said earlier, if we map an address to a uint56, we can, in this deposit function, we're going to increment whatever message.value the person or the user is sending to the vault. And here is where the vulnerability is in the withdraw function. If we read the NAT spec, it says this function allows the user to withdraw balance from the vault. Now, whenever I see a withdraw function, I'm always thinking of reentrancy attacks. Why? Because these sort of functions are very prone to reentrancy attacks. And in this case, I have obviously done it the wrong way intentionally so that we could have this vulnerability and document it. So if you can see here, we've got a function withdraw, which is external, and we have the uint56 amount, which is the specific balance from the message.sender. So whoever calls this function is going to get the amount from that specific user. And then we require that the amount be greater than 0. Obviously, you cannot withdraw any balance if your balance is 0. Like, you cannot withdraw anything if you have got nothing to withdraw, basically. So up to this point, everything looks good, everything looks correct. But here is where the problem is, because we are basically doing the transfer in here. We're calling the call method with the amount that we got out of here from the balance of the user. And obviously we require the operation be successful, otherwise we're going to throw this error, transfer failed. But then we are zeroing out the user's balance right here at the bottom. Now, this does not follow the CEI pattern, checked effects interactions, okay? And this function is very prone to being attacked by a hacker, where the hacker could perform a reentrancy attack. So the first thing that I'm going to do, the first thing that you want to do when you're reviewing some code, is immediately when I see a withdraw function, I'm just going to ask myself a question. Like, is it possible to perform a reentrancy attack? That's the first question that I'm going to ask myself. And obviously, after reviewing the function, we have seen that indeed this function is very prone to being attacked. Okay. Now, what would be the solution? The solution would be to move this line of code up here. Before doing the transfer, you want to zero out the balance of the user. Okay, now if you don't understand much about reentrancy attacks and how to avoid none of that, don't worry. This is not for us to focus on reentrancy attacks. It's just so that we can see a vulnerability. Okay, so this line of code would have to be before the actual transfer. Okay, we want to zero out the user's balance before performing the transfer, and we're going to do an add audit, and we're going to say something like a reentrancy attack could be performed. Wrong pattern. Okay, wrong function pattern. There you go. Awesome. So now we have got our finding, which is that a reentrancy attack could be performed, and there is the pattern of the function is wrong. It doesn't follow the CEI pattern. And now we're ready to, obviously this would be much more complex in a production code base. You would have tests, you would probably have deploy scripts. Obviously, depending on the scope of the security audit, you would do more or less stuff. But yeah, you're gonna have tests, you're gonna have deploy scripts, you're probably gonna have more than one contract that you have to audit. But this is good for us for now, okay? We know that we have just this vulnerability. There is no other vulnerabilities in this code, and we're going to document the finding. Okay, so in our findings.md, I have already made it so that I don't have to type it here live with you. But essentially, what we want to do is give a good title. Okay, give a good title with the severity, and this is the first thing that we're going to talk about: the severity. How to evaluate a finding severity, and to do that, I always refer to CodeHawk's documentation, okay, because it explains it really good. Now, there is this section right here, how to evaluate a finding severity, and you can classify them in 3 different things, okay, high, medium, and low severity. But to evaluate a finding severity, we want to take into account, or is determined based on several factors. So the impact on the protocol, how severe would the potential damage be if the vulnerability were exploited? Likelihood of exploitation, which is how probable would an attacker exploit this vulnerability, and the degree of judge/protocol subjectivity. So we're going to take into account 2 different things: the impact and the likelihood. And obviously the likelihood can be high, medium, or low, and the impact can be high, medium, or low. And depending on how we classify a vulnerability, it's either going to be high or critical, high, medium, 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 low, and low. Or they can also be informational or non-critical findings, gas optimization, stuff like that. But let's just focus on these ones. So they can be critical, high, high, medium, medium, low, and low. Okay. So what would you say a high impact vulnerability is? Well, it's a vulnerability where fans are directly or nearly directly at risk, or there's a severe disruption of protocol functionality or availability. Medium, fans are indirectly at risk, or there's some level of disruption to the protocol. Low impact, fans are not at risk. However, a function might be incorrect, the state might not be handled properly, etc., etc. Now, in our case, because we have a reentrancy vulnerability where an attacker could come and perform a reentrancy attack on our protocol and basically steal our funds, the funds of this protocol are directly or nearly directly at risk. So we have classified this vulnerability as being high, and this is just the finding number. So it's the first finding that is high. So we're going to give it the value of H1. And then you want to give it a descriptive title. And this is a naming convention where you state the contract with the vulnerabilities and the function or the variable name where you can find the vulnerability inside of the contract. Okay. Then you want to give it a description. You want to have a detailed description of where the vulnerability is, what it actually does, how it could be exploited. And I'm not going to read the whole description to you, but I'll leave the link in the description of this video below so you can actually have a look at it. Then the impact, so an attacker can drain the entire balance of the vault, stealing funds from all depositors. And then the proof of concept, or the proof of code, where you basically create via tests or by you writing new lines of code, you basically prove that what you're saying is true, that when you find that vulnerability, you're not just talking out of your ass. Basically, you have to prove that the vulnerability could indeed be performed, or the attack indeed could be performed on that vulnerability. And you also have to make sure that you state, or that you reason why you've given this vulnerability a high severity. So in the proof of concept or the proof of code, you just want to, with code, prove that the vulnerability is high or medium or low, and that it could indeed be performed. Because there are some vulnerabilities that are computationally unfeasible. You would never be able to perform an attack on them because, like, let's say, for example, an attacker could guess the address of a user or the address of the owner. It is computationally unfeasible. It would not be worth performing the attack because the amount of money, time, and energy that you would have to invest into basically guessing the owner's address is stupid. Okay, so when you have a vulnerability that it is prone to being attacked, or that is prone to essentially being taken advantage of, you want to create this proof of concept. You want to create the proof of code to basically prove to the protocol, to yourself, or to whoever you're doing the audit for, that this vulnerability is to be taken seriously, because it can actually be exploited. Okay, that is the whole reasoning behind the proof of concept. And recommended mitigations, you just want to state what things the protocol or the owner of the contract could do in order to mitigate the vulnerability that you've just found. Okay, in this case, like I said, we can move this line before the actual transfer so that it follows the right CEI pattern, or we could use OpenZeppelin's reentrancy guard and apply the non-reentrant modifier as a defense in depth measure. So there you go, the non-reentrant modifier in there. And we also want to have this balances message less than they're equal to 0. So we want to zero out the user's balance before the transfer gets executed, even if we're using the non-reentrant modifier. Okay, cool. So that is pretty much it. Now, obviously, like I said earlier, in production systems, you will have way more files, way more contracts. You will have tests, you will have deploy scripts, you will have a ton of stuff that you will probably have to go through and audit. But that is the basics of auditing. You just want to have a look through and just find any vulnerabilities that you can catch with your naked eye. Obviously, there's all the tools like Slither, Echidna, stuff like that we're not going to talk about in this video because they're to do with like formal verification, stuff like that. So more complex stuff that would obviously allow you to perform way better security audits, because they allow you to test for way more cases and way more scenarios, and just, yeah, it's way more complex, but it is way more robust. Like, this is just the basics. Okay, so I hope you found this video helpful. If you did, leave a thumbs up, leave a like, leave a comment, whatever you want. I'll be uploading more of these videos on a weekly basis, and I will leave the URL for this code base down in the video description, and I will also leave the URL for the CodeHawks documentation. You can have a look at it and read through it. It's actually very interesting the way they talk about all these findings and how to perform security audits and stuff like that. Is really, really interesting. So anyway, hope you found this video helpful. If you did, like I said, leave a thumbs up, leave a like, leave a comment, whatever you want, and I'll see you on the next one.